In this video, I will discuss chi-square test of independence. What is chi-square test of independence? The sample used in this test consists of members randomly drawn from the same population. This test is used to look into whether the measures taken on the two criterion variables are either independent or associated with one in a given population. For examples, we have the level of education and income. Another is the performance in class and the IQ level. Another is the sex of an individual to the academic performance, and etc. When do we use chi-square test of independence? We use it when we try to find out if there is a significant relationship between two variables. How do we use the chi-square test of independence? We use the formula. So this is the same with the chi-square test of goodness of fit, which is x squared is equal to the summation of the quantity O minus E squared divided by E, where x squared is the chi-square test, O is the observed frequencies, and E is the expected frequencies. Example: 90 individuals, male and female, were given a test in psychomotor skills, and their scores were classified into high and low. Use the x-squared test of independence at 0.05 level of significance. So the table is shown. We have the two criterion. We have the sex and the score. Under sex, we have the male and female. Under score, we have high and low. Solving now by stepwise method. First, we have the problem. Is there a significant relationship between sex and scores in psychomotor skills? Next is to formulate the hypothesis. For the null hypothesis, there is no significant relationship between sex and score in psychomotor skill. For the alternative hypothesis, there is a significant relationship between sex and score in psychomotor skill. Next is the level of significance. So we have alpha at 0.05. Then for the degree of freedom, that is equal to the quantity C minus 1 times the quantity R minus 1. So C is the number of columns and R is the number of rows. So from our given example, we have 2 columns and 2 rows. So that is the quantity 2 minus 1 times the quantity 2 minus 1. That is equal to 1. Then for the tabular value, we'll be using the chi-square table. Since we'll be using 0.05 level of significance, locate it on the upper row. Then we have the degree of freedom of 1. Therefore, the chi-tabular value is equal to 3.841. Next will be the statistics. So we have here the table. Under score, we have high and low. Under high, we have observed and expected. Same with low score. So we need to find for the expected frequencies on both male high, female high, male low, and female low. For expected values, multiply the column total with the row total and divide the product by the grand total. First, we have the expected for male and high score. So we have the column total of 50 and the row total of 56. Then divide it by the grand total, which is 90. That is equal to 25.56. Next will be the female high. So we have the column total of 50 and the row total of 44. Multiply, then divide it by the grand total, which is 90. That is equal to 24.44. Next will be the expected for male and low score. So we have a column total of 40 times the row total of 46, then divide by the grand total 90. That is equal to 20.44. And the last one is the female with low score. So we have the column total of 40 and the row total of 44, then divide it by the grand total of 90. That is equal to 19.56. Next is to solve the chi-square using the formula summation of the quantity O minus E is squared divided by E. First, we have the data on the male high. So we have the observed frequency of 18 and the expected frequency of 25.56. Substitute it in the formula, that is now the quantity 18 minus 25.56 is squared divided by 25.56. Next will be the data on female high. So that is the quantity 32 minus 24.44 is squared divided by 24.44. Next is the male low. That is the quantity 28 minus 20.44 is squared divided by 20.44. And lastly, we have the female low. That is the quantity 12 minus 19.56 is squared divided by 19.56. Then evaluate it further. X squared now is equal to 2.236 plus 2.338 plus 2.796 plus 2.922. Then that is equal to 10.292. Next is the decision rule. If the chi computed value is greater than the chi tabular value, this confirm HO. Next is the conclusion. The chi-square computed value of 10.292 is greater than the chi-square tabular value of 3.841 at 0.05 level of significance with 1 degree of freedom. This leads to the confirmation of the research hypothesis, which means that a significant relationship exists between sex and score in psychomotor skill. It implies that females' high scores are more in psychomotor skills than their male counterpart. That is chi-square test of independence. Thank you for watching, and I hope you have learned something.